Alright guys, so we're doing something a little different today. No triangles, no quadrilaterals, well sort of. Anyway, so we're going to talk about what happens when you take something and reflect it or translate it. So a reflection is a transformation representing a flip. So when you take something and turn it, flip it over, kind of like when you're flipping a pancake. A segment connecting a point and its image is perpendicular to line M and is bisected by line M. Line M is called your line of reflection. So a reflection is a congruent transformation or an isometry. So basically, it's not changing in size, it's just flipping over. So let's see what that looks like. For example, we're going to draw the reflected image of quadrilateral W, X, Y, Z. So we're going to take this one here, this one up here, the original. The original has no little tick marks. And we're going to reflect it over line P. So we're going to take this image and we're going to flip it over. And if you'll notice, let's see if I can, okay, where's my, all right, see how point P is way over here now? Because we're taking it and we're flipping it. So what you're going to do is you're going to draw these perpendicular lines. So draw a perpendicular, see how it's perpendicular to line P, and then to go from W to W, from X to X, from Z to Z. It's a lot easier on a grid, I promise. It is a little strange without a grid. So we locate W prime, X prime, Y prime, and Z prime so that the line P is the perpendicular bisector. So this line here is the same distance from everything. So we want our image, our new one, W prime, X prime, Z prime, Y prime, we want it to be an image of W, X, Y, Z. And then you connect these vertices here and you get the same image. So we're going to try that on the next one, okay? So we're going to draw a reflected image of quadrilateral ABCD about line N. Okay, so it would look something like this. So here's your original image, okay? Like I said, it's a lot easier on a grid, so if yours doesn't look great, that's okay, because when I drew mine, it didn't either. Okay, so you have your regular image, so now you go to line A, or point A, sorry, and you draw a line that's perpendicular to line N. And then you do line B, and you draw a line that's perpendicular. Do the same thing with point C. And then you do the same thing with point D. And then you connect your lines here. So AB, CD, AD, and BC. So even with the help, mine still looks kind of cruddy. So just do the best that you can, and I promise we'll get some practice in class. All right, so what happens now whenever you reflect using the coordinate grid? Okay, remember I told you it's a lot easier when you reflect on the coordinate grid? Well, trust me, it is. So what we're going to do is we're going to take these 4 points and we're going to reflect them over the x-axis, okay? So if you think about it, you have, well, I guess it would help if you have your x and y, okay? So if I have this picture here and I reflect it over the x-axis, it's going to be, so I'm going to flip it over this axis, so it's going to be down here, okay? And there's actually a rule, okay? The rule is down here, so I'm going to go ahead and tell you the rule. So the rule is whatever your original values are, so your originals, A, B, C, and D, and all you're going to do when you reflect over the x-axis is all your A's are going to stay the same. So all your A's are going to stay the same. And all your B's are going to change sign. So this 1 becomes -1. This 2 becomes -2. -1 will become +1, and -3 will become +3. So then you get your new points. And then when you draw all of the points on there, you get, see how this is your point A right here? This was the original point A, 1, 1. And the new one was 1, -1, 1, -1. So here's your new A. So this would be your A prime. And then you do that with each one of your points. And then you have your new image. A lot easier on a grid, isn't it? All right, so let's try it. What happens when? Okay, what's going to happen whenever you reflect something? So we're going to take image ABCD, and we're going to do an image under reflection in the origin. So compare the coordinates of each vertex with the coordinates of its image. So use the horizontal and vertical distance from A to origin is 2 units down and 1 unit to the left. Okay, so notice, oops, here's my original. Okay, so here is 1, 1. Here is 3, 2. Here is 4, negative 1. And here is 2, negative 3, sorry. All right, so now what we're going to do is, if you'll notice that point A from the origin, so it says from A to the origin is 2 units down and 1 unit to the left. So A prime is located, repeating the pattern from the origin, okay? And here is the rule. Notice that the rule is you take your original points and just change all the signs. No matter what they are, just change them. And that's the easiest way to do it, okay? So notice that it says, I don't know where they got 2 units down and 1 unit over. I think they meant 1 unit down and 1 unit over, because then from here you'd go 1 unit down and 1 unit over. So see how you'd go 1, 1, then you'd go 1, 1, and be there. So for B, you'd go 1, 2, 1, 2, 3. So from here you'd go 1, 2, 1, 2, 3. So you just follow the same pattern. I think they meant 1 unit down. So that should be a 1. Change that to a 1. It works better when it's a 1. So if we didn't remember this rule, then we could just do this. Down and over, down and over, down and over. But if you just change your points, change your values, I should say, so make everything, just change all the signs. So this becomes negative 1, negative 1, negative 3, negative 2. Negative 4, positive 1, negative 2, positive 3. So this would be rule number, number 2. That's really ugly. So I guess we could call this one over here rule number 1 if we want to get technical. Rule number 1. Okay. Because we only have 3 rules. All right. Now what happens when you reflect the image about y equals x? So remember y equals x is that parent line that goes the positive through the origin this way? Well, it has a rule. And you just flip everything. So this 1, 1 becomes, flip it, 1, 1. 3, 2 becomes 2, 3. 4, negative 1 becomes negative 1, 4. 2, negative 3, negative 3, 2. So voila, just flip them. And then when you plot them, they would look like this. So your original would be 1, 1. Well, when you flip 1, 1, it stays 1, 1, so your A prime is in the same place. Your 3, 2, so 1, 2, 3, 1, 2 becomes 2, 3. 1, 2, 1, 2, 3. And if you think about that line that goes through the origin, it looks like that. So that's the line you flipped over. So this is y equals x. All right, so let's practice some on our own, okay? So remember, when you're reflecting over the x-axis, the x's stay the same. So let's go over here. Let's go L, M, N, P. So this is negative 1, 1. M is 5, 1. N is 4, negative 1. And P is 0, negative 1. So when you flip over the x-axis, all your x values stay the same. So now I've got L prime, M prime, N prime, and P prime. So all these are going to stay the same. 5, 4, 0. So all your x's stay the same. The y values will change their sign. Negative 1, negative 1, positive 1, positive 1. So then when you graph it, it would look like this. So everything just flipped. Okay, so let's look at this. What happens when we reflect over the origin? Does anyone remember when you reflect over the origin? Okay, remember when you reflect over the origin, the rule is to take your xy, take your xy, and you're going to reflect over the origin. So the rule is to change all the signs. So just change all the signs. So we've got all of these same numbers here. So now my L prime, my M prime, my N prime, and my P prime. So everything stays in the same place, it just changes signs. So -1 becomes +1, +1 becomes -1. So this would be -5, -1, -4, 1. 0 stays 0 because it doesn't have a positive or a negative, but 1 will become +1. So your picture would look like this. So you actually reflected it over a line going this way. All right, and now the next one. When you reflect over the line y equals x, remember everything changes places. So your x and your y will become, just make them yx. So all of these numbers will just trade places. So my L prime would be 1, -1. My M prime would be 1, 5. My N prime would be -1, 4. Remember, I'm getting them up here from these points. These are all my original points. My P prime would be -1, 0. So that when I flipped it over the graph y equals x, then it looks like that. And remember, you were flipping it over this line here. Okay? All right, now let's talk about lines of symmetry real quick, okay? Lines of symmetry, some figures can be folded so that two halves match exactly, okay? The fold along that line is your line of symmetry, kind of like in the kite. The long diagonal was the line of symmetry because when we folded it in half, everything matched up. Some figures have a point. A point can be found that is common point or a reflection for all the points. This is known as your point of reflection or your point of symmetry. Okay, so a regular pentagon, it has 5 lines of symmetry that look like this. So basically all you're doing is you're just drawing a line through, pick a corner and draw a line through it perpendicular to the other side. So it looks like this. So you just go to a corner, draw a line perpendicular, go to a corner, draw a line perpendicular. So that would be your 5 lines of symmetry. There is not one point though. There's not a point of symmetry for regular because not all the points are always going to match up. Okay, so let's try that with the triangle. Determine how many, so let's draw an equilateral triangle. That's probably as close as we're going to get it. And we're going to go to a corner and we're going to draw a line perpendicular. Go to a corner, draw a line perpendicular. Go to a corner, draw a line perpendicular. With its equilateral, isn't that line your median, your altitude, your bisector, and everything? So we have 3 lines of symmetry, but there's still not a point of symmetry. So there's 3 lines of symmetry. So 3 lines of symmetry. If you can't read my writing, the word is up here. Lines of symmetry. And there are, it says determine how many lines of symmetry an equilateral triangle has. 3. And then determine whether the equilateral triangle has a point of symmetry. No point. Okay, so no point of symmetry. All right, so now let's move on to translation. Okay, translation is a transformation where all the points move in the same direction and they move the same distance. So if this point moves 5 that way, then this point has to move 5 that way. So it's the same thing, okay? So now what happens is your rule will look like this because you're actually doing something to the x and to the y. Maybe you're moving to the left and down, so you have to move the x over and down, okay? So these are actually pretty easy, so don't let it trip you up any. So what we're going to do is they're wanting us to use this rule. They're wanting us to subtract 4 from every x value. They want us to subtract 5 from every y value. So what we're going to do is you're going to take all your x values and write them down. and you're going to subtract 4 from every one of them. Okay, and I'm going to slide that over just a little bit. So you should have -1 minus 4, 2 minus 4, 4 minus 4, 1 minus 4. And then you're going to do the same thing with the y values. And please note that this is a comma right here because these are your x's and these are your y's. So 4 minus 5, 5 minus 5, 3 minus 5, 2 minus 5. And then just do the math. You're adding and subtracting, okay? So -1 minus 4 is -5. 4 minus 5 is -1. 2 minus 4 is -2. 5 minus 5 is 0. So these would be your new points over here, so that when I took this picture right here and I slid it, then if I took this picture right here and slid it, I'm going to go over 4 and down 5. So you're going to go to the left 4, and you're going to go down 5. And that's what I did to every single point. Okay, so let's try it with this one. So what I'm going to do is I've got L, M, N, and P, and I'm going to write down -1, and I'm going to write down, oops, that's a 1, that's a 3, and P is 1, and they want me to add 3 to all the x values. So I'm going to add 3 to all of my x values. And then I'm going to put my commas because those are going to take care of my x values. And these are primes because these are the image. Sorry. And then I'm going to write down the y values. So 2, 4, 2, and 0. And they want me to subtract 4. So I'm going to subtract 4 from all my y values. These are real easy to do. All right, so what's -2 plus 3? 1. 2 minus 4, it's -2. So there's your L prime. M prime, 1 plus 3 is 4. 4 minus 4 is 0. N prime, 3 plus 3 is 6. 2 minus 4 is -2. And my P prime is 1 plus 3 is 4. 0 minus 4 is -4. So that is where your new picture should be. So you take this one and you're going to add 3 and subtract 4. All right, now, sometimes they'll give us a beginning and an end, and they want us to find out what happened. So you kind of have to use this rule right here. So you're going to take your x and your y, and you're going to do something to the x, and you're going to do something to the y. We don't know something. A and B is our something. And we're going to go through and find out what happens. So if you'll notice here, and I will do this in different colors, our x value is 1. Our y value is 2. So x plus a is -1, and y plus b is -1. Okay? So what you're going to think about is x plus a. Okay, x plus a is where we're going to end up. And they're wanting us to say, they said, find the translation from raindrop 2, so from raindrop 2 to raindrop 3 here. So they're saying to go from 1, 2 to -1, -1. So how many do you have to go over? How many do you go down? So since they're saying that I'm ending at -1, then that's why -1 goes here. And since x is equal to 1, then I'm going to put a 1 underneath the x. So if I subtract 1 from both sides, I get that a is equal to -2. So that means the rule is going to be to take your x and subtract 2 from it. And we're going to do some more of these in class, so please don't freeze up. Okay, so y plus b is -1. So this piece right here, y plus b, is equal to -1. And then y is 2. So I'm going to put a 2 underneath the y. Well, if I subtract 2 from both sides, it cancels out here. I get that b is equal to -1 minus 2 is -3. So that means the y values are all going to move down 3. So this would be your rule. Okay? So what would happen if they wanted us to move from the 3rd raindrop from here to the 4th raindrop? What's going to happen? So using this same thought process, x is -1, so underneath the x I'm going to write -1 because I'm writing this rule down. X plus a equals -1. Okay? So now I know that x is -1. So if I add 1 to both sides, I get that a is 0. So I'm not going to do anything to the x value. And then the y value, since y is -1, because right here y is -1, and y plus b, so y plus b is -4. So y plus b is -4, so I'm going to replace the y with -1, and then if I add 1 to both sides, it cancels, and b is -3. So that means to go from raindrop 3 to raindrop 4, I'm not going to do anything to the x value. Notice the x value did not change. But notice how I subtracted 3. -1 minus 3 gave us -4. Okay? So let's find the translation here from from lightning bolt 3 to lightning bolt 4. So from lightning bolt 3 to lightning bolt 4. So lightning bolt 3, so think about this rule. Guess it would help here. Okay, we're going to go from 3, from 2, 1. Okay, so this is your x and this is your y. And we're going to end up at -1. Is that a 0? -1, 0. So from lightning bolt 3, use the coordinates. Oh, that's a 4. All right, so we're going to end up at -1, -4. Is that the one that we're using? No, we're using 0. Sorry, -1, 0. I can't hardly read this, so that's a -1, 0 because we're on the axis. So this is our x plus a and our y plus b. So this is where we're starting and this is where we're ending. So I know that my x plus a has to equal -1, and I know that x is 2. So 2 plus a equals -1. So if I subtract 2 from both sides, I get that a is -3. And I know that my y plus b has to equal 0, and y is actually 1. So 1 plus b equals 0. So if I subtract 1 from both sides, I get that b is -1. So that means that I'm going to take the x value, and I'm going to subtract 3 from it. And I'm going to take the y value, and I'm going to subtract 1, so that I should get that translation right there. All right. Lots of practice in class. Okay, now if you do successive reflections through parallel lines, they're called a composition of reflections. This one we're going to talk about more in class, so we're just going to kind of fill this in and we're going to go over it some more because to me I think this is a little confusing. So if you take this figure and you reflect it, so notice E moves from here to here. So all the points, it's kind of like reflecting over the y-axis. Okay, and now I'm going to reflect it over line Q, so I've reflected again. Okay, and then it says the translation, translate quadrilateral EFG in line P, the result is E prime, F prime, G prime, H prime, so it's the second one. Then reflect the second one over line Q, and you get quadrilateral E double prime, F double prime, G double prime, H double prime. It does not have the same orientation as this one up here, so it is not a translation image of the quadrilateral. Okay, and we're going to talk about what that means. So just get the terminology, and we're going to go over it in class. Okay, so what about this one? In the figure, lines N and M are parallel, so this is parallel to this. This is your original image because there's no tick marks. And I'm going to reflect it. So if I reflect it, I flip it over. Then I flip it over again. A double prime, B double prime, C double prime does have the same orientation, so it is a translation image. Okay, I know they're very similar. That's why we're going to go over them more in class, okay? Okay, so make sure you come to class with all the notes, and I will see you guys later. Bye.